Welcome to the next session, my dear friends. In the previous session, we are discussing about the controlling equipments for particulates as well as smoke. So here we have discussed all these things: gravity settling chamber. Actually, a small thing here, small correction here in gravity settling chamber. Generally, we take all these equipments are dry, works on dry state. So no spray of water we do here, because that thing also there, but we call them as wet control devices. These are all dry control devices. So in the dry control devices, what we do generally, the gravity settling chamber, if you see, if you look at the gravity settling chamber, so there will be a chamber. So here there will be fans, that means which pulls the whatever the air that is coming into this polluted air. So these exhausters will pull down the pollutants. They will pull down that means a velocity will act in this direction. The settling velocity, we can say this is a settling velocity. So we send the polluted air into it and we reduce the velocity of the polluted air inside this gravity settling chamber, and some downward velocity will work here. So this downward velocity will bring the pollutants down. So the velocity here, gravity settling chambers generally they can only remove larger particulate matters. So they can only remove larger particulate matters where the diameter of the particulate is more than 50 micrometer. So where the diameter of the particulate matter is more than 50 micrometer. And the efficiency, if you look at the efficiency of this, efficiency will be less than 50% because it does not work that much better. So only we are pulling down with some velocity, because velocity is a gravity force. Generally the finer particles, they cannot be controlled by gravity forces. In soil mechanics, if you remove finer particles are controlled, can be controlled with surface forces. So the gravity forces only act on the particles which are larger. So this gravitational settling is at all works only on the particulates which are having gravitational effect on them. So that is, the larger particulates can only be removed in this chamber. So finer materials cannot be removed. That is why the efficiency is very less. Even in the centrifugal separators also. In the centrifugal separators, or we call them as cyclone separators. Centrifugal separators are cyclone separators. So they are also dependent on a force. Here it is gravity force. There they are dependent on centrifugal force. Okay, so here in centrifugal, so the same way, so we are applying some force on the particulates, but it does not work that effectively. It may be better than the gravity settling chamber, but not the best option. Okay. So here whatever we do, so we will be having a shaft. So the shaft will rotate and causes some kind of high pressure at the center, so low pressure at the outside, because of which all the particulate, all the gas, so the pollutant gas will move away from this shaft. So because of the centrifugation, so the particles may get removed. To some extent they will be removed, but not that extent as needed. So here the diameter of the particle that can be removed is approximately in the range of 5 micrometer to 25 micrometer. To 25 micrometer, and the efficiency varies in between 50 to 90%. That is for centrifugal separator. Electrostatic precipitator. So this is very, very important for the examination. electrostatic precipitator. Here we send the gas, okay, so the gas into a alternating current we send through the electrical field, okay. So we will send the gas or particulate matter so into electrical field. So when it goes into the electrical field, so there will be opposite charges. So generally the particulates carry negative charge because they are very fine because of the wear and tear and all. So they carry negative charge. So we will create a positive charge here in this electrical field. So whatever the particulates present inside this will get attracted to this positively charged, and the clear gas, okay, clear air will go out of this electrostatic precipitator. So it works on the electrical field, and this efficiency, so efficiency of this electrostatic precipitator is measured using the formula 1 minus e to the power of minus a into W by Q. So where A is the area of the plate through which we are sending this particulates. Simply we can call the cross sectional area. We can take this a cross sectional area also, okay. And W is wind speed, and Q is the rate of flow. Q is the rate of flow. So using this formula we can find the efficiency of the electrostatic precipitator. Okay. So similarly fabric filters are also, they are filters so which can remove particles with, they are very fine and efficiency is also very, very high. So when diameter of the particle, if it is less than 1 micrometer, so this can be removed, and whereas electrostatic precipitator can remove only up to 1 micrometer, it can remove, below that it cannot remove. So when it is less than 1 micrometer, if it is less than 1 micrometer, so we use fabric filters, completely it removes, and the efficiency also greater than 99%. Generally it removes up to less than 1 micrometer, it removes up to 1 micrometer. Okay. So these are the different particulate removal equipments working on dry basis. So they are wet controlling equipments, that means they work on moisture also. So controlling air pollution, particulates matter using wet controlling devices. So there are three. One is tray scrubber, and cyclone scrubber, and the third one is wet scrubber. Venturi scrubber, sorry, Venturi scrubber. So when the diameter is greater than 10 micrometer, so we use a tray scrubber. So when the diameter is greater than 10 micrometer, we use this tray scrubber. If the diameter is greater than 2.5 up to 10, we use cyclone scrubber. When it is in between 10 micrometer or else the least size, we use cyclone scrubber having efficiency of 85%. And if the diameter very fine particulates are there, so which is a range of, it can remove up to 0.5 micrometer and having efficiency of up to 90%. So these are the different controlling devices based on wet moisture. So here we are having a spray kind of thing, so water spray will be present, so which increases the weight of this particulate matter because of the moisture, and also it creates adhesion. So the particles will attract to each other, so it increases the cohesion in the particles by just forming a layer of water layer on the top of the particulate matter. By this way we can remove the particulates very easily. Okay, so these are the wet controlling devices. And a gaseous controlling device, already I have told you the three things: absorption, adsorption and incineration, or nothing but combustion. So incineration or combustion, so both are same. So these are the different types of controlling devices or controlling technologies. So this is all about the air pollution. Now we are discussing about the noise pollution. So noise pollution, it will be having only three formulas, very important. So if we are acquainted with that three formulas, so that is enough for the examination. Okay. So what is meant by noise? A noise is nothing but any kind of unwanted sound. So an unwanted sound is nothing but noise, which will disturb our concentration, which is not wanted at all. That is nothing but noise. Okay, and that is nothing but noise is also a sound, but it is unwanted sound. So what are the measurement which we do for the sound? How we measure the sound? In the same manner we also measure the noise also. But sometimes noise can be coming from only one source, or it is coming from multiple sources, or it may be coming from one source at different intervals of time, and it may be coming from one source at different intervals of time but at different amplitudes, different intensities. So likewise these are all nothing but, so what we need to do for getting equivalent noise, for getting an average noise, so all these things, finding them is needed. So we need to find the equivalent noise emitting out of number of sources. So for a single source at different durations, what is the equivalent noise? So these things are needed for the examinations. Those formulas we will discuss. Among them, the first formula is sound pressure level. Okay, first one is sound pressure level, so SPL. So this is what we use to measure the sound. This sound pressure level is used to find the intensity of sound, or to measure the sound. Okay, so this we express in decibel. Okay, this we express in decibel. So So here sound pressure level SPL is equal to, sound pressure level SPL is equal to, we represent it with L, 20 log 10 so this P naught is reference. This P naught is reference sound or reference pressure, where P is the pressure of the source in micropascal, where P naught is the reference pressure. Reference pressure, which we take the reference pressure as 20 micropascal. So this is the formula which we use to find the sound pressure level. So this is the first formula, and when number of noise sources, okay, so when number of noise sources are emitting noise, when the number of noise sources are emitting noise of different sounds, of different levels, L1, L2 and so on, Ln, at a time and place, at a time and at a place. Then total sound produced, total sound produced by different sources. Total sound produced by different sources, that is L total, that is L total is equal to 20 log 10 PRMS by P naught, PRMS by P naught. PRMS is nothing but root mean square of all the intensities, root mean square of all the pressure levels, P1, P2, so by this way we can find the L total, by this way we can find the L total. Okay, so this is another way to find the L total. If the same source is emitting different sounds at different time periods, if the same source is emitting different sounds a same source emitting different sounds at different time intervals. A same source emitting different sounds at different time intervals, then average sound of the source average sound of the source L bar is equal to 20 log 10 1 by n, 20 log 10 1 by n sigma 10 to the power of sigma 10 to the power of Li by 20, sigma 10 to the power of Li by 20. N is the number of sound measurements. So at each measurement we will be having L1, L2, L3 like that. So once the sound measurement has come, let it is P1. So L1 is nothing but 20 log to the base 10 P1 by P0, that is L1. So likewise L2, 20 log to the base 10 P2 by P0, this is L2. So likewise we will find L1 and L2, L3, or sometimes L1, L2, L3 will be provided directly. So you can take that also. So by doing that we can find the average sound of the source. Okay. So when this is average sound, we can also find from this equivalent sound, equivalent noise. Equivalent noise, L equivalent. L equivalent is equal to 10 log 10, 10 log 10, 10 log 10 into sigma of 10 to the power of Li by 20 into Ti. So this is equivalent sound, this is average sound of the source, this is equivalent noise. Equivalent noise, Ti is nothing but average, that is time period of that noise and the total time. Ti is nothing but Ti by capital T, Ti by capital T. Capital T is sum of all the times. Capital T is nothing but T1 plus T2 plus T3 and so on Tn. So this is T, capital T. So capital Ti is nothing but small ti, that means T1 by T. So T1 is equal to T1 by capital T. T2 is equal to T2 by capital T. So where capital T is sum of all the durations. Li is intensities. So the sound pressure levels, SPL, that is L. So these are the formulas which are important for the gate examination. And noise standards are there. There are some standards given by the Indian standards, Indian code, noise standards. Noise standards are there. Noise standards. Type of area. Decibels. So sensitive area, and residential area, commercial area, industrial area. So during daytime 50 and during night time 40 for sensitive. For residential area 55 45. For commercial area 65 55. For industrial area it is 75 and 70. So these are the noise standards given by the Indian standards. Okay, so this is all about the noise pollution. This is enough for noise pollution. So what we will do is we will discuss the questions in the next session. We will start the questions of the previous gate from this air pollution, noise pollution. So then we will conclude the total syllabus. Thank you so much.